Now we're going to do some observations. Some of the insight that we need to have is that, number one, it's on gases. Now, what do we know about gases? Give me some insight on what we know about gases.
Gas in air category?
Yep, not as in gasoline, but pressure and volume are related. We talked about that. So, as a matter of fact, P1 V1 equals P2 V2 for any particular gas is a way for us to calculate the pressure and volume of a gas under different conditions, right? So in other words, if we increase the pressure on the gas, it decreases its volume proportionately, right? We could also put temperature in here, and we could say P1 V1 over T1 equals P2 V2 over T2. What does that mean? Well, that means that the pressure is directly proportional to the temperature. In other words, if we heat it up, it expands. We know that because when we bought our girlfriend or boyfriend a balloon and we lived in Minnesota, we took it out of the store that we purchased it in January, and as we were walking along to the car, the balloon kind of went. Wait a second. What's wrong with this balloon? But then we got it back into the warm car, or maybe we brought it into the store. We're like, man, this is defective. And we get it back in the store, it's like, it just wants to be home, right? I don't know. But the relationship is the fact that as the temperature surrounding that balloon was lower, it lost its kinetic energy. That kinetic energy loss relates to a pressure loss, doesn't it? Because those molecules are bouncing on the sides of the wall with less kinetic energy, so the balloon becomes less expanded, contracts, looking like it's deflating. The ultimate to that was our demonstration with liquid nitrogen, last week, where we actually froze the breath in a balloon, right? And we looked at the contents of the balloon after we froze it down, but it completely deflated, didn't it? I have a beach ball, but this beach ball is a little bit unique in that it occupies or holds exactly 1 mole of a gas. What's a mole of anything?
6.022.
Exactly. I'm going to have to teach you guys how to talk in unison. 6.022 times 10 to the 23rd molecules, or things, right? It doesn't have to deal with molecules. It can deal with paper clips. It'd just be a whole lot of paper clips. But 6.022 times 10 to the 23rd things is a mole of things. Things. All right. So what we're going to do is put a mole of gas molecules in here. Now, how do I know that a mole fits in this balloon? Because all gases are, this gas is not the same as oxygen, is not the same as hydrogen, is not the same as nitrogen in terms of grams, is it? No. It's not the same in terms of mass. But one of the other unique properties of gases is that they all occupy the same volume per number of molecules at any given temperature. That's really unique, right? Solids occupy different volumes, and that's why one of the properties of a solid that we can tabulate, that we can put in a table and say, aha, this must be aluminum because it has the density of aluminum. Well, this has the density of gold, so it must be gold. That kind of thing, right? Archimedes was famous for doing what? Does anybody know?
The Eureka and
Was it a bathtub?
that.
Yeah, he noticed, that the water went up when he went in, right? And he realized, obviously, that was a direct proportion to the volume. So he could figure out the volume of a complex object by submersing it and displacing a volume of liquid. And then he could also mass an object fairly accurately, and the ultimate result is, could determine then the density of a solid. Well, gases all occupy the same volume, like I said, and that's a unique property to gases. So, how do we take advantage of that? How do we take advantage of that property? I'm not asking you. This is why I bring more than one balloon.
Oh,
Oh. Oops. Let's see how this one works. Good. How do we take advantage of this property of gases, that all gases, no matter what their identity, occupy the same volume? No matter what the gas, per number of atoms or molecules. Come on, people. How do we take advantage of that? How do we take advantage of that on Valentine's Day? What do we put in the balloon?
Helium.
We put helium in the balloon. Why do we put helium in the balloon?
Less dense than air.
Because helium has the molar mass of 4 grams per mole, doesn't it? What does air have? This stuff. What's it made out of? Oxygen, 20%, nitrogen, 80%, roughly. We can get a pretty good handle on air by those two components. Nitrogen comes as N2, doesn't it?
Yep.
Diatomic molecule. So a mole of N2 would weigh 28, or would have a mass of 28 grams per mole. Oxygen, O2, 32 grams per mole. So roughly, air is about 30 grams per mole. If I filled this balloon, or this beach ball up with air, it would have a mass of air of about, what? 30 grams. There would be about 30 grams of air inside there. Now, these balloons aren't quite as big as a mole, but let's think about that. Let's say that we made balloons and we got mole balloons. Now, a mole of gas, it has a mass equal to its molar mass. That would make sense, right? And since they all have the same volume, let's say that all of these filled up balloons would have the same volume, and they would equal the mass of 1 mole of a gas. If I filled it up with helium, the mass inside the balloon, the mass of gas that would expand this, would be
4 grams.
4 grams. If this were air, which it is, it would have a mass of about 30 grams, right? Now the difference in that 26 grams, different, means that this thing has a mass per unit volume much less, or density, much less than that. And so, if it were filled with helium, it would go boing, up. Well, if it wasn't tied to a string, it'd go boom. If I filled it with hydrogen, hydrogen is H2, right? So that would be 2 grams. So hydrogen is even less massive than helium. Why don't they fill all the balloons with hydrogen?
Don't pop it.
Yeah, popping it's not too bad unless you happen to have a little fire next door or a flame nearby. Or say you pop it with a candle. We'll do that demo someday soon. But that leads to the fact that hydrogen is also a flammable gas, and so if you were to ignite it, it could cause some negative effects at the birthday party or the Valentine's Day. So, now if we filled it with neon, neon is about 20 grams per mole. It would still be a little buoyant. Buoyant means it would float, right? It would still be a little buoyant compared to air. Yeah? So, here, we're gonna do our demonstration now. So, this gas is not helium. It's not neon. But it's a gas. Now this is the demonstration that we're going to pass around. This is not the LLE. I'll announce the actual LLE as we get going. And then I might have you queue up one more video when we actually announce it. I'm going to pray that I have enough gas to do all of this demonstration. Now, how do we take advantage? How do we take advantage of other properties of a gas? For example, the temperature property. Has anybody been out to Albuquerque, New Mexico? Albuquerque, New Mexico, they have this thing every year. It's pretty cool. It's a balloon festival. All these hot air balloons, just hundreds of them, they have go up every day. It's really a cool sight. How does that work?
Heat.
Works by heat. Now, what do you mean?
Heat up the air.
We heat up the air that we fill the balloon with. Now, remember, temperature is directly proportional to pressure, or inversely proportional, well, directly proportional to pressure and volume, right? Or how do I say this? As we increase the temperature, we increase either the pressure or the volume, or both, right? So given the pressure being constant in the atmosphere, and the balloons, hot air balloons are open on the bottom, aren't they? So they would leak if they were filled to a higher pressure than the atmosphere. And so what we do is we fill them with hot air, okay? And so that hot air expands greater than the cold air around it. And so that causes the balloon to have lift, buoyancy, right? Now, what happens as the air inside the balloon cools off?
Goes down.
Lowers.
It lowers, right? Now, what would be some of the best weather conditions to fly a balloon if you were going to go up in a hot air balloon?
Really cold.
Yeah, you wouldn't want to go up on a nice, super hot, sunny day. Why?
You would match the heat of the high air balloon and you won't really go high.
Yeah, you won't have enough buoyancy to effectively lift the hot air balloon. So you also don't really want it all that windy because you don't want to get tore up. You know, when you land, you kind of like it to be a nice, easy landing, not all right, so this is full of a mole of this gas. Now, you've probably all played with
Beach volleyball.
beach balls, right? So there is not any difference, really, between this beach volleyball and anybody else's other than it's got this cute little thing on here that says a mole. All right, so we're going to pass it around, and you're going to notice something. Now, just for the sake of having fun, we're going to blow up another balloon, and I blew that one up with my breath. I'm going to use this tank. Now, this is the beginning of an LLE, all right? So, number one, we're going to do some